dry, the edges would be the part to dry first. You just kind of outline all the topography in the interior of that wall is like it was dusted with chalk or started to dry, or maybe dusted with snow. If this was the Earth, I would say there was snow dumped on some of the ridges on the interior of the rings of Oriental. Also, an interesting part of the discussion that I heard between Reed and Jeremy is that from Glushko to Grimaldi, there are two dark features there that look like commas, but in the wrong direction. But there's also a lot of interestingness, just a lot of geometry and squiggles and dots and lines that are starting to stand out as more small features come into view. And there also is a lot of variation in albedo. In some of those, the two dark features, for example, have on the southern edge of the larger one, the one that's further to the south, there's a very dark, the one albedo, like the southern and western part of Grimaldi. And the one to the north, closer to Glushko, is also that same dark albedo. And then around them there are some very high albedo spots just to the north of the lower, the southern one, and just to the west, the smaller one to the north. Very high albedo, almost approaching the 10, a 9 or a 10, like Aristarchus. And lots of little bright spots are just starting to pop up on in this view. To the north, as you look up at the North Pole, there is a very distinct crater with a lot of a very defined central peak that is also 3 in albedo, and all of that area past it going to the horizon gets lighter and lighter, and is very, very high albedo. And I will go look and find the name of that feature if I can look that up. And then to the south, really getting some interesting geography and topography in the South Pole Aiken Basin. And the view of the South Pole is quite amazing. We've got some Terminator there, as well as the limb view, and there is a very distinct crater right at the South Pole. And I'm going to go look up, I don't believe that is Aiken, but I'm going to go look up the name of that one because it's also giving a lot of good topography due to the shadows that I'm seeing. But that's, I was trying to bound the view that I'm seeing for you, and I got distracted by all of these interesting albedo variations that are popping up in the interior. But that's the view that we see. Just a Babylon diameter to the west beyond is where the Terminator is. Just beyond, I think Copernicus is the easternmost feature that we can see. A very nice ringed, very nice structure crater to the north with a great high albedo central uplift to the north, and the south is dotted by a very characteristic crater with a lot of terrain, shadow features, and I will go try to find some landmarks to put names with those. Any questions for the observation team?
Integrity Science, love the descriptions. You're definitely looking odd up there. Appreciate seeing the training being implemented. Especially interested in your descriptions of the dark patches. You compared the comma-looking features to the albedo you see in Grimaldi, and notice that you're starting to see those color differences popping out. Any observations you want to make, especially when you get on, the PCD in a little bit, would really help us tease out the differences in those dark Mare deposits. Great description, Victor. Keep them coming.
Absolutely will do, and I know you've got descriptions on both of the window observers right now as well. Keep them coming.
great evidence of how well trained this crew is by the science team. NASA astronaut and pilot of the Artemis II mission, Victor Glover, calling down a situation report, noting several different features on the moon in such descriptions, even saying that it looks like snow on some of the peaks. Obviously, we do not expect that to be snow, but referencing that as some of the lighting on how it looks to the Artemis II crew from their current position.
Today being day
The team
6
is
of the
slated to
mission.
be switching their positions at the windows now. Both Reed Wiseman and Jeremy Hansen have been at windows 2 and 3, one taking photos, one making observations and annotations on their portable computing device. At this time, we also anticipate that they are looking at a crater duo. One of those is Glushko, and the other is Ohm. The team is looking to know the extent of Glushko's ray system and how its rays differ in the Mare versus the Highlands. They also want the team to compare the ray systems of Glushko to Ohm. Ohm is considered a young crater. And if you've ever seen a photo of the Richat structure, it's also known as the Eye of the Sahara. It's 40 kilometers in diameter, and that could fit within Ohm's interior. The team is specifically interested in descriptions of that ray visibility, including the color, albedo. Remember, albedo is the brightness or the surface reflection, and the reach. Again, I am using the same lunar targeting package that the crew is referencing on board right now. This helps keep them on time as well as prompt them for when they need to make a call down to the science team and report what they're saying. It also gives them reminders of when they need to swap. We are now 4 days, 20 hours, and 43 minutes.
Science, integrity, that crater to the north, that is, it's like we've got one in the north that looks like just a textbook crater, and one on the South Pole as well. The one on the north, I think, is Pythagoras. And what I wanted to highlight about that is, it is either a very distinct central uplift or just a very defined area of high albedo. If a majority of the crater, especially the floor of the crater, is, say, an albedo of 5, this center, and only a tenth of the diameter of Pythagoras is an albedo of 2, maybe 3, but it is very bright and it stands out. And then between that crater and the actual what is the horizon from here, there seems to be another crater right on the horizon, and right on the edge of that is another patch of that albedo. It seems to be between the two craters. It's hard to tell from this grazing angle, but there is another spot just further north beyond Pythagoras. Between the two, I can draw a picture of this one and show you where that very high albedo, again another 2 albedo surrounded by 5, and most of the area bounding it.
Integrity science, thanks for that. We agree with the Pythagoras assessment. And as a follow-up to your previous report, the SIR had questions about topography comparisons between the North Pole and the South Pole of the moon, if you're willing to provide words on that.
Topography comparisons, absolutely. And if you have any idea what, if you draw a line between Pythagoras and the western edge of the outer defined ring of Oriental, it I would love to know the name of that. The topography differences, now the South Pole has a little bit of a benefit that it has more of the Terminator, and I can see a little more shadowing there, but there's a nice crater right at the South Pole, so that's the main thing defining the topography there. Seems to be quite a bit of elevation change. I can see some very jagged shadows, a 90-degree just to the west of that crater at the South Pole. I can see a very distinct change in the shadow directions, indicating, I don't know, a very high wall or a very deep canyon just to the west of that. And in the north, it seems to be that from sort of the edge of the mare that's dark, which is maybe 1 Pythagoras diameter south. If you draw a ring about that, maybe the top 7 degrees of the moon, and just draw a ring around that. The near side is an albedo of 5 and looks quite smooth from here. And then along the same edge of the mare, that kind of Grimaldi's just outside of, Glushko is just outside of, Carroll Crater is just outside of, and you start to see the stark differences between the darker 7/8s and the 5s and 6s, the 4s and 5s. If you follow that line up to the north, that line is also where the change in topography happens at the North Pole. The line defining the light and dark on the edge of the mare that you can see from Earth. Draw that line, roughly the midpoint of all that, straight to the North Pole. And on the side facing the Earth, you see smoother topography and dotted by Pythagoras and its next door neighbor crater. And then on the far side, you see a lot more cratering and a lot more topography. And again, the far side has the benefit of a little Terminator there, but I am seeing a variation in the topography. It seems to be more jagged and a more challenging place to find a place to land and to even traverse in the south, all around the South Pole. And at the North Pole, it seems to be it would be more challenging to translate on the far side of the North Pole compared to the near side of the North Pole around Pythagoras.
Copy all, Victor. You really help paint a contextual picture of what you're looking at. We really appreciate the way that you're guiding us into the areas you're seeing by drawing comparisons between recognizable features. Thanks for that.
Another little science sit rep moment, something I just heard from the window team is the more I look at the moon, the browner and browner it looks. I thought that was an interesting observation. The two observers have been on timeline, no hardware issues. They did start to talk a little bit about another feature that you'll hear more about on the recordings that they call the handprint. That was at the end of their Glushko and before they moved into their current target. They thought that was worth chatting a little bit more about. And they're preparing to switch after this.
Houston copies and concurs.
Houston and science integrity, another just observation from the human. My eyes have shifted a little bit since I've been up here. I've been wearing my reading glasses to look at the PCD. Well, this is a very taxing event on the eyes, looking out the window and seeing the very bright moon, then coming back inside to the dark cabin and trying to work cameras and microphones and logistics and lunch and those kinds of things, and then looking at the PCD, which is dimly lit. It's just been an exercise. It is a difficult thing to manage it. I'm up and down on the glasses and then having to wait as my eyes adjust when I come back in. As soon as I look back into the cabin from looking out the window, I can feel my eyes adjusting, and I just have to work through it as they adjust.
Appreciate that report, Victor, and know that we are prepared to read you up targets from the ground if that would give you the ability to keep your eyes focused on the moon and not having to swap between that and the PCD. Just let us know.
Yeah, we appreciate that science, and we will also do that for the window teams, and we'll back each other up that way as well. But we appreciate that. We may take you up on that. Thanks.
Continued detailed descriptions from the Artemis 2 crew aboard Orion. Again, this is a test flight, the first time we've flown humans aboard this spacecraft, so every detail, even that it's difficult to look outside the window and then back at the PCD, that portable computing device, every single detail is appreciated as we prepare for future missions. Glover also mentioned that he is now wearing his glasses now that he's in space and that his eyes have shifted a bit. This is something that happens when our astronauts go to space. There is a fluid shift from the lower half of your body up into your head, and that can cause changes in your eyes. It's something that we have seen over time for some crew members, especially now that we have been living and working on the International Space Station for over 25 years. Again, it's clear that these Artemis 2 astronauts have undergone extensive lunar science training, including classroom instruction, fieldwork, and high-fidelity simulations. Training expeditions even took place in analog environments like the Icelandic Highlands and the Kemassassin impact crater in Labrador, where crews practiced identifying and describing geologic features under varying conditions. Additionally, here at Johnson Space Center, Orion mock-ups were used to rehearse crew choreography, including three-dimensional space management with an inflatable moon globe to simulate the flyby. And while on Earth, the crew also used that small lunar passport that I mentioned with descriptions, photos, and prompts to help them study the features we hope they'll see. Now, this is a view from their lunar targeting package at this time, helping them determine what they're seeing on the moon, as well as on the left, keep up with what their next target will be. As you can see, we have got a long list and an exciting day ahead of us. It's now been 4 days, 20 hours, and 53 minutes since Orion launched atop the Space Launch System rocket from Kennedy Space Center in Florida with our 4 crew members aboard. NASA astronauts Reed Wiseman, Victor Glover, and Christina Cook, and Canadian Space Agency astronaut Jeremy Hansen. The Artemis 2 crew passed a major milestone today when they passed the Apollo 13 distance record at 12:57 p.m. Central, 1:57 p.m. Eastern. That Apollo 13 distance record was 248,655 statute miles from Earth.
And Houston, another observation, whole moon. When you look at the moon, something I've never seen in photographs before but is very apparent, all the really bright new craters. Some of them are super tiny. Most of them are pretty small. There's a couple that really stand out, obviously. And what it really looks like is like a lampshade with tiny pinprick holes and the light shining through. They are so bright compared to the rest of the moon.
We copy, Christina. Thank you. Looks like you guys might be doing it, but remind you to swap positions at the window and take your SD cards with you. We're loving everything that you're calling down, so keep it up.
Again, Orion previously surpassed that Artemis, or the Apollo 13 greatest distance from Earth by humans. That was 248,655 statute miles from Earth, and Orion now 250,294 miles away from our home planet. The spacecraft is 9,033 miles away from the moon and growing ever closer. At its closest approach, it'll be about 4,070 miles away, and we will make sure we confirm what that distance ends up being. This is an approximation and an estimate ahead of that moment. We're anticipating them to make that closest approach at 6:02 p.m. Central, 7:02 Eastern, when they are in a loss of signal, transiting behind the moon. They will be the first humans in over 50 years to fly behind the moon and lose contact with Earth. We will regain that contact about 40 minutes later as they reconnect to the Deep Space Network, emerging, and we will look forward to seeing an Earthrise. Again, the crew is currently in their position swap portion on their timeline. This allows crew members the opportunity and the experience of all roles necessary during today's flyby. Right now, those two crew members at the window have swap positions. Again, the crew at the windows swapping positions. Right now, that crew is Commander Reed Wiseman and Mission Specialist Jeremy Hansen, while Victor Glover and Christina Cook serve as their support flyby crew members. That's why you are hearing Victor and Christina during those science situation reports. Those voices will change in about 30 minutes when they take a turn, taking photos and making annotations while at the window.
Houston, integrity. I wanted to provide an observation or a little bit of descriptive nature on something that we saw on the first day we had good moon views. This was when we saw more of the near side, and the ground helped me out with identifying Mare Imbrium. Mare Imbrium, when you have the western limb also in view, looks completely different than the normal view we have of the near side. It is the most striking feature of the western limb view that we had. And the mountain chains that form its eastern side are very prominent, but they actually stand out more than I'm used to seeing even on the western side, and the whole thing just feels like a big bump. It actually looks like a large healing wound with a high albedo forming the mountain chain around the impact basin. and I just don't think I had enough chance to describe how striking it was on that western limb view as we were coming in a couple days ago.
Christina, science, absolutely love that, especially since that's a feature that all of us here on Earth can observe from home. So I'm sure tonight everyone's going to be going out and looking for evidence of that beautiful topography you just said. Thanks for those words.
The view on your screen coming from Orion, a camera mounted on the spacecraft's solar array wing. Toward the right of your screen, the near side is the hemisphere we see from Earth. That is identifiable by those dark splotches, which are ancient lava flows.
Science integrity. A question and a comment. Question is it possible that we're seeing a Schrodinger basin from this vantage point in the Terminator at the South Pole? And the comment is the rays coming out of Ohm are less distinct. We are not seeing the bright rays coming out of it, but the sort of 9 o'clock wedge that is formed by the change in albedo from the interior portion that is to the northeast to the surrounding lighter mare that's 270 degrees to the west. That 90 is very distinct and interior. You got some great descriptions from the two at the window about the colors in there, but in that darker part in that wedge, you've got some really interesting color. Even though the rays, the distinct difference in the albedo almost look like rays, but it's not the rays coming out. It's the just change in that albedo.
Integrity science, that is very intriguing. Those color rays coming out of Ohm rather than sort of albedo. And as answer to your question, we do not think you can see Schrodinger. It's in darkness as of now. But thanks for that Ohm description, and it sounds like the pair at the window's got great descriptions that we're definitely going to dive into tonight.
Okay. If you could help me, I would still love to know what it is. There's a very nice crater. You're going to likely have a lot of pictures of it. What would be right in the Terminator at the South Pole or close to the South Pole, where it's intersecting the Terminator right now?
Yeah, Victor, we're assuming you're talking about, kind of if you're looking at the Terminator, it's basically like 70% down from the North Pole. Is that where you're looking?
Contact, yes, that is where I'm looking.
Integrity Houston, that is an enabled caution for wastewater dump required. We have hit our limit. As expected, no crew action.
Copy, no crew action.
You are.
And integrity science, we're trying to figure out what you're looking at there. Is it like right on the terminator, or is it in the eliminated portion next to the terminator?
While we wait for a response from the crew, the terminator is that difference between day and night, or brightness and darkness, that you see on the moon. We see this from the International Space Station as well, looking down at Earth.
And science from integrity, excuse my space orientation adaptation. If you draw a line between Glushko through the center of Oriental, and then another line from Glushko through the southern tangent of Oriental, that line would almost perfectly intersect tangentially the crater that I'm talking about, and it is on the terminator. So yeah, I think I'm not looking at the South Pole. I was a little twisted.
That line description was really helpful. I have eyes on the SIR right now, and they are actively discussing lunar geography. We will be back with you shortly.
You're hearing a couple voices today in Mission Control Houston. One of those is Dr. Kelsey Young.
Integrity science, we believe that's Zeeman crater.
Oh, I floated away from the speaker. Say it again, please.
We believe that that is Zeeman crater.
Zeeman. Okay, and can you say the first letter? I may be pronouncing that wrong. What's the first letter of that word?
Zulu. It's Z-E-E-M-A-N.
Copy. Thank you for that. Yes, we've got a great view of that. And when I went back to the window just now, the view has completely changed. Our trajectory is taking us to a new view, and I'm looking more into Babalov. I've got a nice, great view into Babalov. I'm actually away from the window right now, so I'm going to go try to give you some bounding words on the view that we're seeing. But I've got to get back to a window in a minute.
Understood, Victor. You're defining new views of the moon in more ways than one.
Again, when you hear calls down to science or from science, that's Dr. Kelsey Young, the Artemis Science Flight Operations Lead here at a console in Mission Control. You also hear communications with the crew from Canadian Space Agency astronaut Jenny Gibbons. She is the Capcom for today. She is a backup Artemis 2 crew member. Those calls from pilot Victor Glover asking about a feature he was seeing, specifically a crater on the moon. Meanwhile, the team here in the science evaluation room was actively working together to determine which feature he was describing. The teams at the window have continued to move through their targets, including Ohm, Aristarchus Plateau, Reiner Gamma, and we are preparing for the cabin and window teams to swap. That's when we'll hear more from Reed Wiseman and Jeremy Hansen when they take on these support roles, while Christina Cook and Victor Glover are at the windows photographing and annotating. As we briefly mentioned, if you look towards the right side of the moon, essentially, this live view coming from a camera outside the Orion spacecraft, and if you look on the right side of the moon where you see those dark patches.
Wow, yeah, I wish I had some more time to just sit here and describe what I'm seeing, but the Terminator right now is just fantastic. It is the most rugged that I've seen it. From a lighting perspective, there are little islands. There are islands of terrain out there that are completely surrounded by darkness, which indicates some real variation in terrain. Up to the north, there is a very nice double crater. It looks like a snowman sitting there, in the 5-10 degrees below the pole in the Terminator. And then on the southern edge, there's almost like a hole. It looks like a hole, and it's the diameter of Vavilov size, just blackness, and then a wall of bright, and then it goes back to the black beyond the Terminator. So there's it looks like there's just a gigantic hole right there. 1 Vavilov diameter east of the Terminator. And as you go south, the Terminator is not a nice smooth arc. It's just jagged. There's almost a 110-degree turn in the shadow as opposed to the nice smooth arc, again indicating some really interesting variations. And I'm sure we'll get some photos of that. And then one of the craters further to the south of Vavilov, maybe halfway down to the South Pole, is not only looks like just a deep hole, and then there's like 2 island rays pointing off to the west and north that indicate very high ridges and very deep canyons coming up out of that crater. So again, just some really interesting visual illusions going on with the shadows there. Like I said, there look to be islands out beyond the Terminator, because some of the things, maybe even a Vavilov diameter into the Terminator are catching sunlight on the peaks up to the north and to the south. It's very, very interesting to see.
Integrity Science, oh my gosh, that was an amazing picture you just painted. I glanced over at the SIR video and I literally saw fist pumps in the air. Those types of observations are things that humans are uniquely able to contribute, and you just really brought us along with you, so thanks for that.
That's awesome, Kelsey. Did you get a sit rep updating you on a slight change in logistics for PCD use?
Christina, this is Houston. We did not, but we will take it now.
We slightly changed the PCD plan for the window observers. The 2 window observers kept their PCD. So in other words, the one at window 2 went to window 3, and the one at window 3 went to window 2 when they swapped rather than staying at the window. We'll plan on all observers keeping the same PCD for all observations.
Copy, Christina. That makes sense to us, and good plan. We are coming up here on a cabin and window team swap. Let me know when you're ready for a quick vehicle status.
As you heard, Science.
Go for the vehicle system update.
Howdy, Reed. We don't have much for you. We just wanted to let you know that toilet right now is no-go for use as we stick with the predetermined limit for now. All crew members, please use CCUs. Otherwise, Orion is looking very good. And you have 15 minutes in this handover time where we expect Victor and Christina to switch to the windows and you and Jeremy to be in the cabin assisting. Let us know if you have any questions.
No questions at all, and they're in the swap right now. The first thing I'll tell you, I floated up to the docking hatch window, and just what I'm going to call the Mari around Oriental just looks so different out the docking hatch right now. It's quite a bit darker. It's the same darkness, if not a little darker than Grimaldi, but it's cool after just being in the 400 mil for the last half hour. Looking up close, I got pictures of everything Ike was just describing on the Terminator. It really is a fascinating Terminator. And then Oriental just looks so dynamic right now. It's very three-dimensional on the docking hatch compared to what I was just looking at through the 400 mil.
We love it. We are getting a sneak preview from one of our SAW cameras at what you're looking at, and we see some of what you're describing. We cannot wait to see your photos. Thanks.
Yeah, Jenny, I wish you had some longer lenses on those solar arrays so you could see the whole moon, but man, it is, or the up-close moon, not the whole moon, but it is just fascinating here. It's so cool.
All right, MPO and Inco, take notes. We want a zoom lens on those saws next time. Thanks, Reed.
Affirmative.
As the crew gets ready to switch positions from the window crew going back to the support crew and the support crew flying up to the windows, this view inside the room, Capcom Jenny Gibbons speaking with the crew, Canadian Space Agency astronaut. The crew has continued to provide excellent descriptions of what they are seeing on the lunar surface. In this picture, or in this live view actually, from Orion and a camera mounted on its solar array wing, if you look at the dark portion on the right side of the screen, those are visible from Earth. That's considered the near side. Those are ancient lava flows from a time early in the moon's history when it was volcanically active. And if you look towards the left, there's that dark, large crater that appears to the left of those lava flows. That's Oriental Basin. It's about 600 miles wide, and it straddles the moon's near and far side. And this mission is the first time that humans have ever been able to see this with their eyes in the daylight. Again, you hear conversation about that Terminator. You have a great view of that as well. That's the difference between light and darkness on the moon. Victor Glover explaining that as a very jagged looking Terminator due to the peaks that they're seeing and the craters that they're seeing as they prepare to cross over the far side. You also heard science officer, the Dr. Kelsey Young, Artemis Science Flight Operations lead, sharing with Victor Glover that his responses are truly something that only human eyes can discern or provide. So we've previously discussed how having humans observing the moon on this mission is being combined with lunar robotic data to help us maximize what we know about the moon. So part of that data comes from the Lunar Reconnaissance Orbiter, or LRO. This orbiter provides the robotic foundation that makes Artemis 2 lunar science possible. LRO has been orbiting the moon for 17 years, which makes it the longest operated lunar orbiter in history. And it's also the only American spacecraft dedicated specifically to lunar science and exploration. Artemis 2 lunar observations are designed to complement data like the detailed surface images from LRO. So while LRO provides those detailed high-resolution maps of the moon's surface, the Artemis 2 crew adds human observations that focus on regional context and relationships between features, giving scientists a larger geologic picture. Now, this combination of robotic and human observations strengthens lunar science. LRO delivers precise and repeatable measurements over long periods of time, while the Artemis 2 crew contributes real-time visual descriptions and context that robotic instruments alone cannot provide. The best description I've heard while preparing for this mission is to compare the difference in looking at the moon with your own eyes on Earth and trying to take a picture with a camera. The camera truly never does it justice, and it's much easier to describe and perceive what you're seeing with your own eyes than to take a photo. These Artemis 2 astronauts can rapidly scan wide areas and adjust their focus in real time, as well as describe relationships between features. The crew will also observe the same regions multiple times under changing lighting conditions during the flyby and provide perspectives that would take robotic missions years to accumulate. During the Artemis 2 mission, LRO is also attempting to observe some of the same lunar features that the astronauts are studying. Collecting this data simultaneously highlights how different instruments and human eyes provide complementary information about the moon. This LRO data plays a direct role in preparing for future Artemis missions. Its measurements of topography, surface temperature, composition, radiation, and lighting conditions are used to assess hazards, identify safe landing sites, and locate potential resources such as water ice near the lunar South Pole. This mission, Artemis 2, represents the point where years of robotic preparation are paired with human exploration for the first time in the Artemis era. So together, LRO, the Lunar Reconnaissance Orbiter, and Artemis 2 are demonstrating how NASA moves from mapping the moon robotically to exploring it with humans. We are laying the groundwork for future Artemis missions and sustained lunar operations. A check-in with Orion. We are now 4 days, 21 hours, and 22 minutes into the flight of Artemis 2, our crew aboard the Orion spacecraft. We are now 8,153 miles away from the moon, 250,742 miles away from Earth. The spacecraft is traveling at 1,030 miles per hour.
All right, Houston, the professional science update giver is now in seat 2. That is where Victor is, and Christina is nestling into seat 1 with the long lens, and we're just getting ourselves oriented here. It's a cool view in the cabin. It's actually a cool view to be off the camera now and looking at my crewmates getting up to their observation post and looking in. It's super fun.
Copy, I'll read. We like it.
As we heard confirmation from NASA astronaut and commander of Artemis 2, Reed Wiseman, they are now switching positions of the support teams and the observation teams. So initially, Reed Wiseman and Jeremy Hansen were at windows 2 and 3 in the Orion spacecraft, taking photos and making annotations in their PCDs, portable computing devices. They were also giving audible descriptions into their PCDs, wearing headsets with microphones and providing recordings that the science team will be able to listen to later. We were hearing from NASA astronauts Christina Cook and Victor Glover as they made observations as part of the support team. Now, as these teams are swapping, we anticipate hearing more from Reed and Jeremy as they'll be on the support team, while Victor and Christina will be at the windows taking photos and making annotations.
For the science team, if they can mark this time, I just covered up window 4 to block out the ambient light from a very bright planet Earth. And it'll be interesting to see if in the data Victor and Christina see any differences from me and Jeremy with that window blocked. It's a lot darker in the cabin now.
Copy, Reed. We're taking note, and we'd be curious too.
We are live in the Artemis mission control room during the lunar flyby of the Artemis 2 crew, the first humans to fly by the moon in over 50 years. Orion launched 4 days, 21 hours, and 30 minutes ago atop the SLS rocket, Space Launch System rocket from Kennedy Space Center in Florida. Our 4 crew members inside the spacecraft are transitioning their positions. The cabin and window teams have swapped. Currently at the window, we have Victor Glover and Christina Cook, NASA astronauts, and serving as support, Reed Wiseman and Jeremy Hansen. For our crews at the window, they are using handheld Nikons with an 80 to 400 millimeter zoom lens. There are also GoPros on each of the solar arrays on Orion, and that's where this view is coming from right now. We have an interior camera of the crew as well, but they have dimmed the cabin lights. They've actually turned off the cabin lights to allow them to better see outside of the spacecraft. This also helps prevent any reflections from lights inside the spacecraft reflecting onto the windows while they are photographing the moon. We talked a little bit about the views and the cameras being used on the Orion spacecraft. And again, we do have GoPros on the tip of each solar array wing. Now, the bandwidth is a little bit limited because having a crew on board, we do have to downlink a lot more data. That includes their environmental control and life support system. We are not the only data, this view that you see, coming down from the spacecraft, and so we do rely on sharing some of that with the other flight controllers in mission control. This helps the team monitor all systems aboard the spacecraft and ensure the safety of our astronauts. We are standing by for a situation report from the crew aboard the spacecraft. They've been imaging the whole moon. There is now a new crew at the window. That would be Victor Glover and Christina Cook. And so, being it's their first time since they have moved up to the window positions, they have a chance to orient themselves and describe and take pictures of any color or albedo variations across the surface. Reminder, albedo is the brightness or reflectiveness.
Integrity Science for a science sit rep when you're ready.
Houston Integrity, we have no external view of the moon right now for the floating crew members, so my only science sit rep is that we have Victor in window 3 doing observations and Christina in window 2 with the long lens.
Integrity, we copy. Are the shrouds still on windows 1 and 4? And if so, would you consider trying to get a view through one of those windows?
We cannot take the shroud off of 4 because the Earth is too bright and it's impacting Ike's peripheral vision. And then I can get a grazing glimpse out the docking hatch window. I can see Oriental south down to the South Pole. And the primary thing that I see from Oriental right now is just the long trenches that come out. And, when you come out the north side of Oriental, the ejecta kind of boulders across the northern half of the far side. But coming out the southern half of Oriental, I just see those large, here they look like gorges or almost like rain when it comes down the Grand Canyon and fingers off into the desert, kind of what it looks like. Also, Burgess Alpha is extremely bright. It's the brightest thing that I can see. Even brighter now than Aristarchus, which is heading off to the Terminator. It's almost impossible now to see Aristarchus, the thing that Jeremy and I look so much at. I can just barely see the crater rays from Ohm, and I would say for albedo right now, I would go back to Cromartie is still extremely dark, especially in that southwest corner, and there are parts of Oriental and the outer ring of Oriental that reach that same level of darkness, especially the rings of Oriental reach the same level of darkness as Cromartie. And then south of Cromartie, Jeremy and I were noting a few other just really dark areas of cratering, Mare there, and those have that same darker albedo, but Burgess Alpha is the brightest, and Cromartie is the darkest.
Integrity Science, that was a great description. Thank you, and thanks for the docking window geometry to give us that description. Any comments before you go on the annular ring in Oriental?
The annular ring, which I think everybody kind of describes as like a pair of lips or a kiss on the far side of the moon from here, is very circular in nature. The northern part of it is wider, darker. The southern part is much lighter. It is very neat looking, and but it is far more circular than I remember it looking in our training. The darkness of the northern side of the annular ring is the same darkness from here out this docking hatch window as the center mare in Oriental. Not quite as dark as Gravani, but it is probably only because dust and lunar regolith has kind of impacted over time.
Reed, that's exactly what we were looking for. Thanks so much. You have heart hands coming out of the SIR.
Say that
just saying that the sir was really excited about that. That annular ring was something we were really eager to hear about, so thanks.
Yep, you bet. And now Victor and Christina are moving on to Oriental. I got them situated over there a little bit late.
That was NASA astronaut Reed Wiseman, now providing a science sit rep as he is away from the windows most of the time. He is working as the support person along with Jeremy Hansen in the spacecraft, as Victor Glover and Christina Cook are now at windows 2 and 3, able to photograph the moon. Christina and Victor are also providing recorded information to their portable computing devices, that's their PCDs, and the science team will have access to that at a later time. They will then review it and compile all of this data to help further our understanding of the moon. One of the items you heard mentioned was Oriental Basin. This has been a very exciting opportunity for the crew. They have all been very excited about seeing Oriental, as well as the science team has been looking forward to it. It is known as the Grand Canyon of the Moon, as we discussed earlier. From the pictures, the science team is hoping that the crew will take centered images of the entire basin and surrounding craters in a single frame, but also use those 80 to 400 millimeter zoom lenses to create a mosaic entire basin. With their unaided eyes, the science team is hoping the crew will describe southern dark annular ring, which you heard Reed just describing, as well as any color, albedo, texture, or topography across the mare patches and ring mountains. Science team reports that the observations will be used to study the geologic evolution of the youngest lunar basin and to inform formation hypotheses for the annular ring. And again, another fun fact about Oriental is the diameter is the same distance between Johnson Space Center, where we are today, and Kennedy Space Center, where the crew launched on April 1st. The Orion spacecraft on the Artemis 2 mission, now 7,373 miles away from the moon, 251,130 miles from Earth. Again, the Artemis 2 crew passed the Apollo 13 record of the humans farthest from the Earth today at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time. That distance set by Apollo 13 was 248,655 statute miles. We have clearly passed that, and we expect to pass that by about 4,105 miles. That will be when the spacecraft reaches its farthest distance from the Earth. It could be around 252,760 miles, but again, these are approximations and our targets, and we will make sure to report back the final numbers once we have them. We have some refined times of when we expect to have Earth set of Earth behind the moon while Orion flies behind the moon. That would be about 5:41 p.m. Central, 6:41 Eastern. The spacecraft would make its closest approach to the moon at 6 o'clock Central, 7 Eastern, and that would be about 4,066 miles. And then at 6:02 p.m. Central, and the spacecraft will reach its farthest distance from the Earth. We anticipate that'll be about 252,755 miles, which would be 4,111 miles farther than Apollo 13. We would see Earthrise again at 6:21 p.m. Central Time, and a few minutes later, regain communications with the crew. Currently aboard Orion, Victor Glover and Christina Cook are the two team members conducting lunar flyby observations, meaning they are using the Nikon cameras to photograph the moon, and their PCD, or the portable computing device, to conduct annotations. They are both recording information that will be downlinked to the science crew, and tomorrow morning the science team will have a conference with the team while the information is so fresh. They'll be speaking with the crew about their observations and their data collection. Otherwise, most of tomorrow, Flight Day 7, is considered an off day. We are on Flight Day 6 of the Artemis 2 mission, the first time in more than 50 years that humans will observe the moon directly, providing a critical opportunity to practice how lunar science will be conducted during future Artemis missions. If you're just joining us, the crew is well into their lunar flyby observations, and we anticipate that we will hear from them soon. A few times every hour, they are slated to call down with science sit reps or situation reports. We most recently had one from Commander Reed Wiseman. He and Jeremy Hansen, mission specialist, were first at the windows today to photograph and make annotations of what they were seeing. Therefore, we heard more from Victor Glover and Christina Cook earlier in the day during those first blocks. But now that Reed Wiseman and Jeremy Hansen are on the support side, they are the ones calling down what they are seeing from windows 1 and 4. Earlier, we heard that the Earth is so bright in window 4, they have had to temporarily cover it with a t-shirt. The moon preserves a near-continuous record of solar system history that has been erased on Earth because the moon doesn't have an atmosphere. So things that we experience on Earth, like weather or plate tectonics, don't really apply. So the lunar surface retains evidence of ancient impacts, volcanism, and solar activity that scientists can study today. And studying the moon helps scientists understand how planets formed and evolved, how the moon influenced our own planet Earth's history, and how the sun shaped conditions across the inner solar system. The moon also serves as a unique platform for studying the broader universe. Artemis science is designed around questions best answered by humans, working alongside robotic systems, combining decades of robotic lunar data with real-time judgment, context, and adaptability that only humans can provide. This mission, Artemis 2, is serving as a proving ground for lunar science operations, which allows NASA to test how science is planned, executed, and supported during a crewed deep space mission ahead of our future Artemis flights.
Integrity, time for a window team position swap. So Victor and Christina, please switch places if you've not done so already, and remember your SD card for the camera.
We're in the swap right now. They're wrapping up their last comments, and they'll switch over and change guards in the long lens.
Copy.
As you heard in that call, it is now time for the team members at the window to swap positions. That means Victor Glover and Christina Cook will be switching roles. One of them has been photographing the moon with a Nikon with an 80 to 400 millimeter zoom lens, while the other was making annotations on their portable computing device. And both are recording audio that the science team will be able to listen to. We are now 2 hours and 10 minutes until we expect to lose signal with the spacecraft as they fly behind the moon. And the next target for the crew is considered a crew choice event. They have the option to focus on any regions or patterns or features that interest them. The science team has asked the crew to capture pictures that illustrate their choice, as well as at different zoom levels, and to describe why those certain features or regions caught their eye. Those recordings are part of what are being saved on their PCDs, portable computing device that will be sent to the science team for analysis. The crew has been allotted 8 minutes for this crew choice event, and it's also a time for a scheduled sit rep or situation report. So we expect to hear them calling down what they are seeing soon. Something that the crew or that the science team has used to help prepare the crew is a cue card. These ask for a feature ID if they happen to know the type or name, and if it is a target. Of course, in this situation, when they have a crew choice, they do not need to, it may or may not be a target. They want to know the location and the observation style. They've also asked for the geometry of what's being captured, the size, shape, boundary, and preservation, as well as the color and shadow, so the color tone, the albedo, that reflection or brightness, and any shadows or illumination. Next, they're interested in structure and texture. That includes slopes, structures, and textures, of course, and geologic relations, like association to other features, any contact to those features, and of course, their thoughts, impressions, or interpretations. They are interested even in emotions and excitement that the crew may be having. This flyby day has been practiced in many ways, even in Sims here in Mission Control Houston. The team also conducted some field work, learning how to look for specific geologic features. They also photographed a large globe, and the science team helped them determine which features they would be targeting and how to look at those. We have a few more minutes that the crew would be photographing their crew choice. Again, this is NASA astronauts Victor Glover and Christina Cook at the windows. They will then move on to another discussion portion. This is for the far side albedo, that reflectiveness, and color that they are seeing. We heard earlier about some browns seen on the moon, which is very interesting, especially here from Earth, where we are just seeing whites, grays, and maybe even black at some points. When they get into that discussion for far side albedo in a few minutes, the theme is looking to know how that color and albedo is, what those variations look like across the far side. On the right side of your screen, the Science Evaluation Room, or SIR, where team members are looking real time at what the crew is seeing, and even earlier where...
Houston Integrity, ready for science zero?
We'll take it.
Okay, the crew has swapped positions. They're in their crew choice element. I've been listening to both of them for a little bit, and they're really enjoying. They both decided to pick the Terminator, and they're spending a lot of time looking at the Terminator, just talking about the resolution that they can see, the depth of the craters, and the is just looking out the window, and I'm sneaking a peek in T-shirt window. It looks like, I don't have the best angle here, but it looks like Aristarchus is on the limb of the moon now. It's amazing how quickly it changes as we speed around the far side of the moon, stuff that's leaving our field of view, and now we have a lot of the dark side of the moon that, it's missing for us right now, but it would be in view if it was lit at all.
Jeremy, Science, thanks for that sit rep. Do have a question. A few times we've heard you and the other crew describe change during the course of your flyby. Would be interested in future descriptions of more verbosity about how it's changing. Thanks for the great sit rep.
Kelsey, sounds good. We are definitely keeping an eye on that. My eyes are just not readjusted. The moon is so bright when you come back to the window. I was just in the interior of the cabin. I've come back to T-shirt window, and it's just overwhelming brightness, and my viewing angle is a bit challenging. So I won't be able to give you great observations from this window, but I will talk about something that I was talking a lot about in my recordings earlier, which was we've been talking about some shades, and so we have obviously the dark and the light gray, and then we talked about naming some colors, a brownish hue and a greenish hue. And I'll tell you, like right now, Aristarchus, the plateau is hard for me to see from this window, but that had greenish hues to me. It was very unique. I didn't see anything like that anywhere else on this side of the moon. And then I see a lot of these, what I would call brownish hue areas. There's a number of them. And they, for example, in the northwest corner of the highlands, to me it looks like the brownish hue is caused by ray or ejected material landing on the highlands, and then we obviously see the ray areas as a lighter albedo, but in between the rays where the deposit would be thinnest, that is what it looks like is causing the brown to me. So I saw that in the northwest side of Aristarchus, or sorry, that dark area of the highlands, northwest side of the highlands. I saw it in the highlands to the east of Glushko, and then I see those same brownish hues west of Oriental, and I drew a contact there on OneNote, but that's a huge region, kind of like a piece of pie with the point of the pie pointing at Oriental and then going up towards the northern side of Hertzsprung. And that is an area that just looks like a different, that brownish albedo.
That was fantastic, Jeremy. We had heard rumors of the green and brown hues, and so you really read my mind on asking about those. Understand they likely didn't have any contact with each other the way that you described them, but please correct me if I misunderstood that. And then last thing, I'll make the same offer we made to Victor earlier. If it would be helpful for us to verbalize any targets so you can stay at the windows and keep your eyes adjusted to the moon, please let us know.
If you got something you want us to look at, Kelsey, you can send it on up.
Definitely not looking to interrupt your flow, Reed and Jeremy, only offering assistance if you guys want to keep your eyes off of the PCDs.
Oh, I see what you're saying, okay. not really science related, and we definitely learned this at Apollo, but the thing that is just most fascinating, I think, to me and Victor right now is even as rugged as the far side looks, when you look at Oriental and Home, it's rugged. But man, when you look at the Terminator, it is just like impossibly rugged, and it reminds you that the whole far side is that way, and just the Terminator is really bringing out the shadows and the hills and the valleys, and it's unbelievable. It's like no surface of the Terminator is not marked by meteor impact, and it is very impressive to look at that, and you realize that is true across the whole far side. You just can't see it due to sun illumination right now.
Reed, Houston copies, and we were commenting on the same thing. Even from our view, the Terminator looks absolutely alien because there's just so much texture in there that we're just not used to seeing. So thanks for sharing that with us.
There's also, I don't know the name of it, coming out the southwest of Oriental, right on the southern Terminator, is just a massive crater. I don't know the name of it. Maybe you can look on the solar array wing video and tell me it's right. It's the southernmost crater you see on the Terminator right now.
We're looking for you.
Think of you now. I think of you now. I think of you now. Oh, oh. I think of you now.
We're loving that picture. Thanks for showing us. And Reed, as an answer to your last question, we believe that is Chebyshev crater. And the sir agrees with that.
Okay, the picture I was just showing you is an 8X iPhone out the docking hatch with a high grazing angle. It's just amazing.
We love it. Thank you.
This is Artemis Mission Control in Houston, Texas. Mission elapsed time, 4 days, 22 hours, 12 minutes into the flight of Orion. This is Lunar Flyby Day for the crew aboard the spacecraft. Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen are now the farthest people to have ever traveled from Earth. This a live view from inside the spacecraft. They have turned off the lights so they're able to see outside and photograph the moon better with no reflections from inside. And for a very brief moment there,
Integrity Science, thanks for those iPhone views. It's helpful to see what you're seeing.
we very briefly saw NASA astronaut Reed Wiseman showing a picture he took on his phone of the moon. We do expect to get all of the photos that the crew is taking today, and we cannot wait to share some of those with you. But pretty cool in the meantime, just to see one quick shot from what the crew is seeing. And this view from outside the spacecraft on Orion's solar array wing. Orion is now 6,643 miles away from the moon and continuing to grow closer. Again, their closest approach will be about 4,066 miles. The best comparison is if you held a basketball at arm's length. That's about what it would look like to the Artemis 2 crew at their closest approach. This view showing at the very top, a camera coming from Orion, continuing their flyby of the moon. We have 3 more flyby observation blocks after the completion of this one. Down in the bottom left of your screen, that's the SIR, the Science Evaluation Room, where team members are continuing to work through all of the targets that the crew is photographing today, and they've helped identify some of the craters and some of the other items that the crew has seen on the moon's surface. Down on the right is Artemis Mission Control here in Houston. Those 2 rooms down at the bottom are just down the hall from each other. And we are just a few minutes away from the next cabin and window team swap. That means Victor and Christina, who have been at the windows, will fly to the cabin, the background essentially, and be their support crew for Reed and Jeremy. Reed and Jeremy will move back up to the windows. crew is continuing their discussion portion of the flyby in the lunar targeting package, where it says far side albedo/color. They are looking, the science team is looking to get a good understanding of what the crew can see on the far side at this point, and its brightness as well as any colors. We did hear earlier Canadian Space Agency astronaut Jeremy Hansen reporting that they could even see browns and even greens on the moon. I'm really looking forward to seeing those photos. And in just a couple of minutes, the teams will swap from the cabin to the window. Another rundown of just how this flyby is choreographed inside the spacecraft today. So these activities have been timelined, and there are these 5 blocks of time during which the crew is going to be observing the moon from Orion's windows. Now we are just coming up on the end of the second block, and we'll start the third soon. So at any time during those blocks, 2 members are at the windows working in a pair. One is taking photos from window 2 and has a blue shroud over the window to help prevent any reflections from inside the spacecraft. They are also using an 80 to 400 millimeter zoom lens. And the other astronaut on the window team will be in window 3 using their portable computing device to make annotations. Now, again, both of those crew members are making audio recordings of what they are seeing, and we are not hearing that right now. Those are going to be downlinked later to the science team, who will evaluate them and use that data to inform our understanding of the moon. Those 2 crew members at the windows swap roles.
Integrity Houston, it is time for another swap between the cabin and the window teams. So we have 15 minutes of handover time, and then we will expect Jeremy and Reed at the windows and Christina and Victor at the cabin. I have no new vehicle updates for you, but I do have a photo location for some photos on Ike's PCD, and I want to let you know that Jeremy's family have arrived in the viewing gallery.
Okay, Jenny, we copied most of that. The only thing we're missing is what you meant about the photo location on Victor's PCD. And hello to my family. I think that must be Catherine and Devin that are there. And I'm glad they made it into the viewing room. And we copy. It's time for crew swap. The A team's coming out of the windows and the B team's going in.
Okay, copy. All I meant to pass for Victor's PCD is that there are some late load photos that were requested that are now in his favorite photos folder. And you're exactly right. We have Catherine and Devin here. They give you a big wave, and they're super excited and happy to see part of what you're seeing.
Okay, copy, Jenny. We're not sure what we're looking for in the PCD, but we're going to poke around and we may be calling you back about that one.
All right, that's no problem, and it's unrelated to flyby.
This is Artemis Mission Control here at Johnson Space Center in Houston, Texas. And as you just heard, Capcom, or Capsule Communicator Jenny Gibbons, Canadian Space Agency astronaut and Artemis 2 crew backup, relaying to the teams in Orion that it is time for a swap from the cabin to the window teams. We're now at the tail end of the second lunar flyby observation block. Again, we have 5 of these today. Most recently, Victor Glover and Christina Cook were at the windows photographing and making annotations, while Reed Wiseman and Jeremy Hansen were in the cabin providing support, whether that is SD card help, but also science sit reps calling reports for what they are seeing on the moon or anything about the vehicle status. With that call to make a swap, Reed and Jeremy will be back at the windows, making observations for what they see at the moon and taking photos. Again, you're watching live coverage of NASA's Artemis 2.
Something that's really awesome up here is we now have the moon and the Earth in window 3 simultaneously, and the moon is a gibbous, and the Earth is a crescent. And I'm guessing in about 45 minutes we'll have 2 identical crescents as we change our position in the universe.
That is pretty darn cool. Thank you.
That's the Artemis 2 crew, the first astronauts to fly by the moon in more than 50 years, reporting that when they look out of window 3, one window, they're able to see both the Earth and the moon at the same time now. Now, obviously, our view is from a camera on the solar array wing pointed at the moon, and we hope to see that view of both the Earth and the moon soon. Some upcoming times for what you can expect. In about an hour and 40 minutes, we will have Earth set. And during that time, we will have a view of Earth going behind the moon. Shortly after, just a few minutes later, we will lose signal with the Orion spacecraft. This is tracked as it is going behind the moon and out of reach of the Deep Space Network. At 6 o'clock p.m., the spacecraft will make its closest approach to the moon at a distance of about 4,066 miles. At 6:02 Central, the spacecraft will reach its farthest distance from Earth at about 252,755 miles. Of course, these are approximate, and we will make sure to provide you with the final distances once those are confirmed. At 6:21 p.m., we will have Earthrise from the Orion spacecraft, but we will not have communications with the spacecraft until 6:25 p.m. Central, when we expect to acquire signal with them after they've emerged from behind the moon. Again, you're watching live coverage of NASA's lunar flyby for the Artemis 2 mission, first crew to fly beyond the moon in over 50 years. The astronauts inside the spacecraft are switching positions, 2 at the windows and 2 serving in support roles, before they start their third timelined flyby observation for today. We've heard great calls from the crew so far describing what they're seeing, all well trained by the science team here on the ground. Another major milestone for the crew today will be to experience a solar eclipse from their capsule. No one on Earth will experience this solar eclipse. To the astronauts, this will look a lot like a total solar eclipse on Earth, except the moon will be huge compared to the sun. Whereas if you're standing on Earth and looking at a solar eclipse, the moon and the sun appear to be about the same size in the sky. As the moon begins to cover and then uncover the sun, the astronauts will see a partial solar eclipse, so that's before and after totality, and during that time frame they will have to wear eclipse glasses so they can safely view this phase. They also intend to capture images of the sun's corona during the eclipse. This is a rare glimpse at the innermost corona that will only be captured by the astronauts' cameras. During the eclipse, we also look forward to the crew members describing what they will see, which includes unique light features like the shape and size of the corona and potentially even lunar dust. At the same time, Venus, Saturn, Mars, and Mercury will be near the sun, so they may be able to identify what part of the sky they're looking at. This can help train future Artemis astronauts on what part of the sky they're seeing, which is useful knowledge in challenging situations when they may need to rely on that information instead of instruments for navigation and orientation. That eclipse window will last about an hour, and it'll happen near the end of the day today, closer to 7:35 p.m. Central, 8:35 Eastern. As you can see in this live view from Orion, the spacecraft is maneuvering around the moon, and the views of the moon have changed since we started our broadcast. The near side is now very far to the right side of your screen. This is the side that we can see from Earth. That darkened portion are ancient lava flows. The crater down towards the bottom of the moon is Oriental, and this is a crater that was previously never seen before by human eyes until this mission. Everything to the left of Oriental is considered the far side. And this is what we typically do not see from Earth. And just a reminder about this view, this is coming from a GoPro camera mounted on the tip of one of Orion's 4 solar arrays. Each solar array has a camera mounted on it, and the bandwidth is limited due to we have a crew on board, and this is our first flight of crew aboard the Orion spacecraft. So having a crew means we have to have an environmental control and life support system. There's a lot of data around, a lot of data to bring down for the crew members to keep us up to date on everything happening aboard the spacecraft. So we have to share our bandwidth when it comes to imagery and data. They will switch positions at the windows and will be prompted by the ground to do so.
Houston, integrity for SITREP. First of all, I'll just talk about the experience that I had during Victor and my observation time. It was an incredible experience. We definitely noted how much more you can see with the zoom lens. Even though we have a great visible eye image, there's just a lot of texture that just pops right out at you when you can zoom in. So almost just using it like a telescope, the camera lens. We really enjoyed our discussion time. That was a great innovation on the lunar targeting plan. We were both able to describe a lot more kind of with flow, I would say, when we were talking to each other. And it was also, we sort of were able to bounce ideas off of each other and come to new conclusions. We had, I think, a very successful talking through. It lasted just a second or two, and I actually couldn't even make it happen again. But something just drew me in suddenly to the lunar landscape, and it became real. And the truth is, the moon really is its own body in the universe. It's not just a poster in the sky that goes by. It is a real place. And when we have that perspective and we compare it to our home of the Earth, it just reminds us how much we have in common. Everything we need, the Earth provides, and that in and of itself is somewhat of a miracle, and one that you can't truly know until you've had the perspective of the other. I'll switch into some logistics stuff. The Peltors, both their batteries stopped providing the active listening, but we have verified they're still recording, and so we are able to have discussion time and hear outside our recordings by just moving the ear cup off of the ear. Other than that, everything's working well technically, and we've been able to find all our targets, and we're having a really great time.
Thanks, Christina. We copy those logistics for the Peltors, and also thanks for bringing us into the cabin with you with that description.
Right on time, NASA astronaut Christina Cook, a mission specialist for Artemis 2, calling down a science sit rep, a situation report. Good news, reporting that she and her teammates have been able to capture all targets that were listed. Christina also gave a vibrant description of just how it feels to be there and to see the moon up close and not just something passing in our night sky. Currently, the team members at the window are Reed Wiseman and Jeremy Hansen. Meanwhile,
Integrity cabin team for window shroud.
We're listening. Go ahead, Jenny.
Hey, Victor, we have a temperature constraint on the windows, and the shroud might be getting us close, so we just want to check on the state of window 4's shroud, whether you believe it's still necessary because maybe things have changed with our viewing, and if so, we would like to request to have the shroud removed.
Houston, we believe it is necessary. We pulled it off just in the corner. It is very bright. It definitely would affect our night vision and maybe comfort. But is there a time? Can you tell us when we would have to take it off by?
Unfortunately, since it's been on for a while, we are going to have to request that the shroud is removed, and we can recommend something that could block the light but just create a bit of distance between the window and whatever is covering it. Something like a t-shirt would do the trick and help.
Okay, we're removing the shroud, and we'll make it work. Thanks.
Thank you, Victor. We know it's pretty bright in there now with that window uncovered. We will also offer that airflow on the window would be helpful. So if you want, you can also retrieve the condensation hose, which should be friction fit onto one of the diffusers. And that on the window would also help.
We can easily point a diffuser at the window, so we're going to start with that. And it's pointing at the window now.
Okay, we'll take that, Victor. Thank you. Please keep us updated.
That call from Capcom, Jenny Gibbons, CSA astronaut and Artemis 2 crew backup to the crew aboard Orion, letting them know that they will need to remove the window shroud they had placed on window 4. They initially placed that shroud there to block out some of the light from the Earth. It was extremely bright coming in the cabin and interfering with some of their viewing opportunities out at the moon. This was a request from ground teams to ensure that they are protecting other systems, and the crew has been offered the opportunity to use something else to cover the window. Meanwhile, Reed Wiseman and Jeremy Hansen continue with their lunar flyby observations. They have just looked at Glushko Crater. That's about when we heard that call down from Christina Cook with that description of everything she had been seeing during her observation period and what she was seeing at that time. The science team asked this crew to take centered images of the entire crater and their ray system in one frame. They're also interested in knowing the brightness, texture, and extent of Glushko's rays and how they differ in the mare, or that sea area, versus the highlands. Glushko is considered a young lunar crater, and these observations can help understand material properties of those craters.
Science, integrity. First, I wanted to start off with connecting with what Christina said, that it was very moving to look out the window. I had the unfortunate sequence to start looking out the window and then moved to the long lens, and it was hard to speak looking through the Zoom because I went straight where Christina went, and I was walking around down there on the surface, climbing and off-roading on that amazing terrain. I also want to underscore something that she said. As we continue to explore, when we actually do go down there to the surface, I know for safety reasons that we would never send someone alone, but I just want to really emphasize how important the discussion time was. When we started to talk, we not only got better science discussion, we got better human connection, and so doing this as a pair, we just learn and grow together, and that's just super important, so thank you for adding that to this plan. Reed just passed me a note that the Oriental Basin annular ring has a similar albedo to the center, but a different color. It has more brownish tones in it, and he said it's very distinct now that he's been staring at it.
Victor, thank you. You got a cheer from science there, and we all just went on that moonwalk with you, so highlighting how important it is to talk about these things. I also want to let you know that we have Deanna Glover with us in the viewing gallery. She's all smiles.
Well, you just got a bunch of cheers up here. Hey, babe. I love you from the moon.
We love that we got a hey babe too, and we also have one of your lovely daughters here watching you guys work.
Thank you guys for doing that and for supporting them through this. And to all of you, Genesis, Maya, Joya, and Corinne, I love you. And Deanna, I love you. I'm glad you get to be there.
We've had some really sweet words from the crew members aboard Orion today, as their families have been able to filter in and out of the viewing room here at Artemis Mission Control at Johnson Space Center in Houston. Victor Glover also giving a great science sit rep and just a description of how it must feel if you were down on the lunar surface while he was looking through that 80 to 400 millimeter zoom lens. He also expressed how important it was to be able to talk through that real time with Christina Cook and stressed the importance of that on future missions, that it not only made their discussions better, but also more human. Glover and Cook are in the support roles right now, not taking photos or making annotations at the windows, but they are also encouraged to have their midday meal at this time. For lunch today, those two crew members have options of beef ravioli, salmon, butternut squash, sweet and savory kale, pickled beets, cherry blueberry cobbler, tuna noodle casserole, tomatoes and artichokes, broccoli, and chocolate peanut butter bar. Once Glover and Cook return to the window portion of their flyby today, Reed Wiseman and Jeremy Hansen will get into their midday meal. Again, this is the third of 5 scheduled blocks for our lunar viewing today, and if you were watching at the start of the broadcast, you can definitely tell the difference in the distance from the moon. We are now 5,518 miles away from the lunar surface, and again, expecting the crew to get about 4,066 miles away. They are currently 252,050 miles away from Earth, and every mile is a new record, having surpassed the Apollo 13 milestone for furthest distance earlier today. If you look down to the bottom right of the moon in that darker looking area, that is Oriental Basin. We have continued to lose views of the near side. It is just barely visible over towards the bottom right side of your screen. And then you'll also hear later about that terminator. That's the line between light and darkness while on the moon. It is really exposing some of those craters at this time. A couple of the other features in view right now are Hertzsprung Basin and Vavilov Crater. Hertzsprung Basin is nearer to the center of the moon, closer to that terminator line right now, and Vavilov Crater is just on the outskirts of it, closer again to the terminator. Towards the bottom of the moon and to the left of the terminator line, or currently shadowed in darkness, is Apollo Basin.
Science from integrity. Let me find out how far we are from the moon right now. But our view is about a third of the moon is in eclipse. That beautiful terminator is out there calling to me. We're 4,691 miles from the moon. And what looked like in the terminator about a third of the way up from the southernmost part of the terminator looked like a dinosaur print if one was running to the northwest. Now is clearly a crater with a bunch of craters around it. And that terminator, I can only see about half of it. I'm looking through the docking hatch window right now because we have the Z9 in window 1. But that terminator has moved. I guess I've been using Vavilov the whole time, so it's gone 2 more Vavilov craters to the west. And so a few more features are starting to peek out into the sunlight there with that low sun angle, and so you still have ridges and valleys showing up very clearly. A very jagged terminator, and a few islands of light out there with some high elevation shining in the sunlight in that darkness. And on the eastern side of the moon, the Romaldi appears to be one of the farthest east features, and that is maybe 5 degrees from being right on the limb and going off over the horizon. It is interesting, just looking at Oriental, that my first impression of it is all of the dark areas appear lighter, which I think makes sense because it is now facing, well, it's still relatively the same to the sun, but my angle to it is different. So I'm looking at it from a little more, even further to the side as we pass it. But all the darker features appear to be just a little bit lighter from this vantage point. The darker ring structure in the outer and inner ring, and the interior, as well as the annular ring portion, everything seems to be just a smidge lighter at this point.
Thanks for that description, Ike. Any additional words you can provide on Oriental would be wonderful, as that is such a high priority target for us. And while I have you, as we get closer to target 15, which is the Terminator target, if you can find Zeeman Crater again that you were looking at earlier, everything to your left of Zeeman would be getting into the South Pole Aiken area to help you orient yourself.
Zeeman is a great waypoint out there. I definitely see it. Yeah, Zeeman is very easy to find, and that is awesome. Thank you for pointing that out. Feel free to do that as often as you think of things. Let's see, looking back at Oriental. Okay, another thing, after looking through the zoom camera, man, you guys are smart. You probably did this on purpose, but after looking with my plain eyes and then going to the 400 millimeter zoom, now looking at it, I see the cliff faces. If you were standing in the center, that inner and outer ring have definitely some real terrain to them, and now I can see that as terrain. Now that I look at it even with my naked eye, I can tell that there's a lot of elevation and that, like I said, a cliff face on that eastern edge where all the darker deposits are, and it's just the scale now. Looking at it from far away, before it seemed like flat with color painted on it, but now that I look at it, I can definitely see that there is, different depositional characteristics. So the darker is some other material, but there's also some shadowing going on because of the cliff face that is a part of that crater wall.
Great description, Victor. Thanks, and really interesting to hear now the distinction between shadow and color. Before I let you go back to other observations, you mentioned that Reed saw a browner hue to the annular ring than the rest of Oriental. Are you seeing that from your vantage point?
The way that I'm looking at Oriental, again, I'm still in the docking hatch window. There's like a thermocouple right here in the center of the window, and it is the orange Kapton tape color, and so it is unfortunately it's like trying to look at stars, next to a metropolis. I think it's drowning out any color that I could pick up from the moon. I am not able to see that color, but I have not looked at it through one of the forward face, from one of the windows 1 through 4. I think when I get away from this Kapton tape strip that I would be able to see the variation that Reed's talking about.
That is great feedback operationally. Thanks, Victor. I'll leave you to it.
Calling me
you with a question from the window team.
Integrity, this is Science here with you.
Yes, they have a question to help inform a theory that they're sort of tossing back and forth. What is older, the Mare seas of the near side or Oriental?
Stand by, Integrity. We're going to get you a little geologic history here. Integrity Science back with you for some lunar volcanism when you're ready.
Go ahead.
You're making our day down here getting to talk about lunar volcanoes. Oriental, as far as Mare go, is younger than almost all of the Mare on the near side. The exception are features like Aristarchus, which really pop out to you guys and really pop out to us here on Earth. That is younger, but other than that, Oriental is pretty young as far as Mare go.
Kelsey, thanks for that. We love lunar volcanism too. How about when the actual crater was formed?
Yeah, we're going to get you an age for Oriental, and while we're getting that, Christina, can you, maybe you've heard the window team talk about the sort of contacts around Oriental, but because that material is so much younger, if anything pops out to you about physical relationship between that and surrounding terrain, we'd love to hear it.
Yeah, definitely. They are discussing a contact relationship that could explain some of the color that they're seeing in certain areas. And so it was really about the ejecta of the creation of the basin and understanding the superposition of its ejecta and Mare on the near side or other features. So thank you. We'll take the insight when you have it.
Thank you, Integrity. And I know Jenny wants to get to you with some topics, so I'll leave you with Oriental is 3.8 billion years old.
Copy that. So that's on the older side. The actual basin is very old.
Correct, as is the case with a lot of mare. Typically the big basin formed and then the, volcanic eruption was able to punch through the crust where it was weakened by that basin formation.
Perfect. Tracking. Thank you.
NASA astronaut Christina Cook calling down some questions to the science team on console. The voice you're hearing with those answers is Dr. Kelsey Young. She is joined by Trevor Graff on console today. Christina asking about the age of Oriental and specifically the mare regions. Those are those dark regions that you see. They are paved or filled by volcanic deposits.
Better answer.
Integrity, it's about time for a position swap at the window. So we will ask Reed and Jeremy to swap positions. And I'll remind you again about your SD cards. And Victor or Christina, I have one window task for the cabin team when you're ready.
They are swapping, and I'm ready.
All right, Tina, we found a way that we can reinstall the shroud on the window. We understand it's pretty darn bright compared to everything that you're looking at. So in order to reinstall it, we will ask that you retrieve the condensation hose and you install it on a friction fit on the cabin air outlet port. That's right by one of your diffusers. You're going to point that little condensation hose such that the air is flowing over the window pane. Let me know when you're ready for the stowage location.
Ready.
Christina, the hose is in locker A1.
The crew has gotten a go to reinstall that window shroud they were using to block some of the earth shine.
Copy.
This view coming from inside the Orion spacecraft as the crew members are swapping windows, specifically Reed Wiseman and Jeremy Hansen. They've been our crew members at the windows taking photos, making annotations, and making recordings that'll be downlinked later to the science team for review. The science team will have a conference tomorrow morning with the crew to get any fresh perspectives or things that they learned during the flyby. Again, we are now in the third of 5 observation blocks for the crew scheduled for today. During this flyby, Orion is passing around between 4,000 and 6,000 miles from the moon and providing the crew with a full view of the lunar surface. It's a higher vantage point and much farther than Apollo's lunar orbits on average. So from this view, astronauts can observe both the North and South Pole and large-scale geologic features in one single view. We are now just under an hour until Orion passes behind the moon, and we lose communication with the crew. They will be out of reach with any of our deep space network antennas. That loss of signal will last about 40 minutes, and we expect to regain communications with them once they fly behind the other side of the moon. While they are behind the moon, they will also reach their max Earth altitude as well as their closest approach to the lunar surface. The view you have right now is a live stream from a camera on Orion's solar arrays. You are looking at a live view of the moon, and 4 people are inside that spacecraft taking pictures of it, telling us everything that they are seeing. The first humans to do so in over 50 years. They'll be sending those pictures down for all of us to enjoy, and of course, especially the science team, who are very excited for what they are learning today. It appears the Artemis 2 spacecraft, Orion, is now under 5,000 miles away from the moon. Again, we expect their closest distance to the moon be about 4,066 miles. That is an estimate at this point, and we will make sure to share that closest approach distance once we receive it.
Cool the window with the condensation hose, or did you want us to put the shroud back on and cool the window at the same time?
Victor, we definitely want you to cool down the window with the condensation hose. It's crew preference whether you put the shroud back on. The hose will allow you to do that if it helps with your lunar flyby.
Okay, copy. We're going to do both at the same time. Thank you.
Houston, copy.
Houston, thank you for that suggestion. The cabin is darkened again, and that makes a big difference for the imagery. And for science, we are now seeing a half moon.
Thank you, Victor. We're happy to hear it, and we see half moon, full moon joy still.
Crew reporting from Orion that they are seeing half the moon, which is about what it looks like here from this view from the spacecraft. However, what has become a little bit of a catchphrase for this mission, everyone is reporting full moon joy. We are keeping up with which targets the crew is tracking through their lunar targeting package. They are just wrapping up their second.
Science integrity, another observation the window team commented on and Christine and I discussed a bit is in Hertzsprung. The solid and intact crater is very smooth. If it were a dirt road, it's very hard packed, and then you go outside of it, and that outer crater, that's the one that is older. It is a little rougher and more jagged. It starts to get into more loose-looking terrain, and the smooth interior also causes the craters that are inside of the larger crater, the smaller craters, to have really sharp edges, sharp, distinct edges. And just a general comment on that area, Hertzsprung, that whole area, the average albedo there is darker. That is, I would say, 3. And the average albedo around Oriental and between Oriental and Ohm, excluding the wedge, the darker wedge, is more on the 6-7. And that they also seem to be different texturally. Christina described it earlier around Hertzsprung, and then from Hertzsprung toward Oriental, there appears to be a frozen, a rippling pond but frozen, or like choppy waves when it's windy out, choppy water, and then it freezes instantly. That's the texture. If you walk down there barefoot, it looks like it would be hard on your feet, like lava after it's cool. It would be pokey. Except for right there in the center of Hertzsprung, it looks paved, like a paved road, nice and smooth.
Victor, that's a wonderful description. Going from a paved road to lava reminds us of the Icelandic highlands. Thanks for that.
In science, another in the interior of the very intact, the interior of the intact crater at Hertzsprung is albedo variation. I think I heard one of the window crew maybe say color variation, but definitely albedo variation. There's lighter patches and slightly darker patches. It's not swirling, it's just patchy. It just has spots that are lighter, and I would say a predominantly darker average area.
Great descriptions, Victor. Thanks. Not swirly, just patchy is really helpful for us.
Really great descriptions coming from
Science, the window team is hitting all the targets. They are on plan and starting the discussion of the Terminator. And boy, I'm loving the Terminator. I think I know it's not purely a moon feature, but what it does to the features of the moon, to the terrain, I've probably spent the most time describing into my recordings and thinking about and looking at the Terminator. There's just so much magic in the Terminator. The islands of light, the valleys, what look like black holes. You'd fall straight to the center of the moon if you stepped in some of those. It's just so visually captivating that the Terminator is the most striking thing that I've seen so far.
We've been loving your evocative descriptions, Victor. You really are bringing us along with you, and we're following along with visualizations that pale in comparison to your descriptions. Thanks. Integrity Science, one more question on a status of what the window team chose to observe for crew choice.
Window 2 talked about Vavilov, look for suspended dust, and the Terminator. And Window 3 about the experience and about the three-dimensionality of the moon this close.
Wonderful.
And
Thanks,
another
Victor.
observation about Oriental, I would say, is the features going off to the southwest, the two large, almost look like scratches in the surface. I don't know if they're rays or canyons or collapsed lava tubes, but two distinct features that are almost parallel going off southwest from Oriental Basin. They are the first things that made me notice parallax of our trajectory looking out at Oriental. That and in the inner walls of the east side of the crater rings, you really get a sense that we're flying over something with elevation and terrain, and they look different from this orientation.
Love to hear it, Victor. And you had it that those chains are actually crater rays, secondary craters formed from the formation of Oriental.
Yeah, speaking of crater rays, the crater rays that are going off to the northwest, that run off toward Hertzsprung and I believe toward Vavilov. I'm not looking at it right now, but those crater rays are very interesting. They're all very small. I know you've imaged this, but they're all small and they look like, a big impact launch rocks and things that made smaller impacts down the way. But something very interesting, and again, you can see this in imagery, but some of them are parallel, and then some of them converge toward the center of Oriental. And then I think I even saw some that maybe diverge, not diverge, but that are convergent, which indicate multiple large impacts that created a lot of secondary impact crater rays.
Fantastic, Victor. And I'll note that we can infer that you're looking down at your freshly named Integrity crater, which is near the end of one of those beautiful crater rays from Oriental. Thanks for the description.
Yeah, you're welcome. And Integrity is easily identifiable with the naked eye from this point.
We've been hearing some great situation reports from Victor Glover, the pilot of the Artemis 2 mission, calling down to the science team he is seeing. And one of those things is Hertzsprung Basin. If you look just to the right of the Terminator, that is the difference between light and darkness on the moon. You can see what he's describing when he says Hertzsprung Basin and how it looks a little bit paved in the middle there. It's almost in the very center of the moon in this view, coming from the Orion spacecraft and a camera mounted on its solar array. We are now 4 days, 23 hours, and 23 minutes into the flight of Artemis 2, and we are standing by for their lunar loss of signal in about 43 minutes. Again, the spacecraft will fly behind the moon, and during that time, we won't have communication with them. They will be out of reach of our deep space network. However, we will regain communication with them approximately 40 minutes later when they come around the other side of the moon. The crew aboard the spacecraft are currently discussing the Terminator, that difference between day and night. The science team is interested in learning about the topography and the color of the lunar surface, and it's already been very interesting to hear that they have seen colors like greens and browns while looking at the moon.
Alright, guys, that's it for me from today. Good night.